Welcome to my video tutorials dedicated to analysis and calculation of electronic circuits. This time I'd like to show you an example in which will be included all material which was presented on previous lessons. So let's get started. We have such scheme which includes resistance R1, R2, R3, R4, R5, voltage between input nodes U, current number 1, current number 2, current number 3, and let's add one more resistor number 6 and respectively current I4. So we decided that we need to find the current I1, I2, I3, I4. So just these four currents. How we can do that? First of all, we need to make some approximation of this scheme. So let's calculate the total resistance which is connected to the input nodes. Means that resistor to which is connected the input voltage. First of all, we need to find the resistor R56, which is the combination of two resistors R5 and R6. This is the resistor R56. Okay. So initial scheme will have the following view. And on this step we will find the equivalent resistor R23 like a serial connection of two resistors R2 and R3, and the resistor R456, which is the combination of also serial connection of two resistors R4 and R56. So now we have such scheme, which at the moment includes only three resistances, and the last two ones are connected in parallel. So let's find the resistance R26, like a combination of two parallel resistors R23 and R456. And at the last step, we see the scheme which includes only two resistors R1 and R26. And now we can find the total equivalent resistor R16, which is connected to the input voltage. Okay, we did it. And now let's see what we have for calculating the currents in four branches. First of all, we have the voltage, input voltage, which is connected to the scheme, 16 volts of direct current, 16 VDC, and 6 resistors R1, R2, R3, R4, R5, R6, with respective nominals 3.5 ohms, 1.5 ohms, 1.5 ohms, 1.8 ohms, 2 ohms, 3 ohms. And we need to find the currents in four branches, in exception of one current in branch with resistor R4, you remember. So we found all resistors, we made all transformations, and let's scroll to the start of this task when we found the first equivalent resistor, R56, and let's find its value. R56 is 1.2 ohms, okay. Next, let's find the value of resistor R23 and R456. Three ohms, okay. Resistor 26 have the value of 1.5 ohms. And equivalent resistor of the wall scheme R16 have the value of 5 ohms. We remember that we have input voltage U and input current I1. How we can find this input current? We use the Ohm's law, and I1 is U divided by R16. And its value will be 3.2 amps. And now we need to find the voltage on resistor R26, taking into account that we know the current I1. We know Ohm's law that voltage is resistance times current, and the value of this voltage is 4.8 volts of direct current. So we found the voltage between two nodes. Between these two nodes are connected two resistors R23 and R456. Respectively, we can find the current I2 which goes through the resistor R23. Let's do that. Great, its value is 1.6 amps. Current I3 is not exactly that current I3 which we need to find on the following step. In this example, we may use the Kirchhoff's first law, and I3 is I1 minus I2. Its value will be 1.6 amps. And not it's just a current which go through the resistor R456, only that. We know these three currents, I1, I2, I3, and we need to find the voltage U56 between two nodes to which resistor R56 is connected. Its value is 1.92 volts of direct current. And now finally we can find that current I3 which we had to find initially in task, which go through the resistor R5, and the current I4 which goes through the resistor R6. The value of I3 is 0.96 amps, and the value of current I4 is 0.64 amps. And let's write down the answer.